Hello students, I welcome you all to the online video lecture on course Turbo Machines. In this video lecture, we are going to solve a numerical on steam turbine, that is a single stage impulse turbine, okay, which comes under the module number 3 of VTU Mechanical Engineering syllabus. This is the important numerical which is asked in the year January 2014 for 10 marks, okay. So if you have not subscribed the channel yet, kindly like, share and subscribe my channel. Watch this video till end, you'll get the solution for this problem. Okay, so let us read the problem carefully. In a stage of an impulse turbine provided with single row wheel, the mean diameter of blade is 1 meter. It rotates at 3000 rpm. The steam issues from nozzle with a velocity of 350 meter per second and nozzle angle is 20 degrees. The rotor blades are equiangular. The blade friction is 0.86. Determine the power developed if the axial thrust on blade ring is 120 newtons. Okay. So this is an important problem on single stage impulse turbine. So after reading the problem carefully, let us try to write down the given data. So write down the solution. Write down the solution given data. The first, it is the single stage impulse turbine. It is a single stage impulse turbine. Okay. Now, which is provided with the wheel? The wheel diameter is 1 meter. Diameter of wheel, which is represented by capital D, equals to 1 meter. Okay. Next, the rotation speed of wheel is 3000 rpm. Okay. Rotation speed, it is represented by capital M, equals to 3000 rpm. That is revolutions per minute. The steam issues from the nozzle with a velocity of 350 meter per second. The velocity of steam which is coming out from the nozzle, or the velocity of steam at which it hits the blade, so that is nothing but V1. It is represented by V1. You can say it as exit velocity of steam from the nozzle or absolute velocity of steam at which it hits the first row of moving blade. Of course, this type of turbine, it is a single stage impulse turbine. It will have only one set of nozzle and one set of moving blades. Okay. So the absolute velocity of steam at the inlet of moving blade or outlet from the nozzle is represented by V1. Okay, steam velocity, it is represented by V1. So V1 is given by 350 meters per second. The nozzle angle is represented by alpha 1, nozzle angle alpha 1. Okay, so remember guys, the nozzle angle is given by alpha 1, which is equals to 20 degrees. Okay. The rotor blades are equiangular. The moving blade angle is represented by beta 1 and beta 2 at the inlet and exit respectively. In question, if he gives the equiangular rotor blades, then you are supposed to take beta 1 equals to beta 2 because they are equiangular. Equiangular in the sense the inlet angle is equals to the outlet angle. Equiangular blades. Equiangular moving blades. Equiangular moving blades. So you are supposed to take beta 1 is equals to beta 2 here. Okay. Next, the blade friction is 0.86. So blade friction, or you can say the coefficient of blade, it is represented by CB. So CB is nothing but the ratio of VR2 by VR1. VR2 by VR1, it is nothing but 0.86. Okay, next. So what is to be determined here? What is to be determined? So we need to determine the power developed if the axial thrust on the blade ring is 120 newtons. So axial thrust is given. Axial thrust, it is represented by F suffix A. It is nothing but 120 newtons. 120 newtons. So here we need to get the value of power P. To find the value of power P. Okay. So this is the given data. Now this solution, or the solution for this particular problem, we can use a graphical method to solve this numerical. So in order to solve the graphical method, before going to the solution, we have to find or we have to draw the combined velocity triangle. We have to draw a combined inlet and outlet velocity triangle. So let us try to draw the combined velocity triangle. It is a totally a rough sketch. It can be used as a reference for the graphical sketch. Okay. So this is not as per the scale. So this is u here. This is u. U stands for the tangential velocity of the runner or the blade. This is the absolute velocity v1. V1 is absolute velocity of steam at the exit of nozzle, and it is inclined in nature at an angle of alpha 1 with respect to horizontal. It has two components, namely vertical and horizontal component. Okay, so just join these two points. So this will be relative velocity component VR1. VR1 is nothing but relative velocity component. So due to the friction between the steam and inner surface of the blade, so this component comes, that is relative velocity component at the inlet. Now the vertical component of V1 is VF1, and join these two points. So this will be the inlet velocity triangle, and of course beta 1 is the angle made by the VR1. So remember, for V1 alpha 1, for VR1 the angle is beta 1. So the horizontal component of V1 is VU1, the tangential velocity component VU1. So this is the complete sketch for inlet velocity triangle. Now similarly, we can draw the outlet velocity triangle. Yes, this is the outlet velocity triangle where this diagonal, this principal diagonal is VR2, relative velocity component at the outlet. This component, or this is the absolute velocity at the outlet, V2, and its vertical component is Vf2, the flow velocity component at the outlet, and similarly this vector is Vu2, the tangential velocity component at the outlet. So V2 makes an angle alpha 2 with respect to horizontal, and Vr2 makes an angle beta 2 with respect to horizontal, with the horizontal. The algebraic sum of Vu1 and Vu2 is delta Vu. The algebraic sum of Vu1 and Vu2 is delta Vu. Okay, name all the points A, B, C, D, E, and F. Now this will be the reference figure to draw the final sketch on graph paper. Okay. Now we can proceed for drawing the combined velocity triangle in your graph paper. Okay. Say for example, this is your graph paper. Say for example, this is your graph paper. So just hold in a landscape mode. Okay. Now here you can start the solution just by leaving 1 centimeter from the bottom, and you can draw the horizontal line here. Okay, you can start sketching the graph here. Okay, this is a base or u, the tangential velocity u. Okay, I hope this is clear. Now let us try to draw the sketch or the combined velocity triangle on graph paper as per the scale. So let us adjust the scale first. Okay. Now here the speed is given n equals to 3000 rpm and diameter is given d equals to 1 meters. So therefore the tangential velocity u is given by pi d n by 60. U equals to pi d n by 60. Substitute the values. Pi into d is 1 meter into the speed is 3000 rpm. 3000 rpm divided by 60. So the value of u is, the expected value for u is 157 meter per second. 157, this is in meter per second. Okay, so this is a value for the tangential velocity u, the tangential velocity u. Now here we have to take an appropriate scale. We have to take an appropriate scale here. Let us take the scale. The value of u is 157 meter per second. So let us take appropriate scale to convert the dimensions from meter per seconds to the centimeters. Okay. Let us take the scale. Scale 1 centimeter equals to 40 meter per seconds. Then the value of u will become, then the value of u in terms of centimeter is 157 by 40. 157 by 40. So that will give you the value of u in terms of centimeter 3.925 centimeters, and approximately you can take it as 4 centimeter also, 4 centimeter also. Okay, because this is a graphical method, we can't take the exact dimensions in your graph, so you can take 4 centimeter. It is acceptable. The plus or minus some zero point 0.1 centimeter error is acceptable, right? Okay. Now first we have to draw the line CD on a graph paper. Just try to draw the line CD here. So CD or U equals to 3.925 centimeters. 3.925 centimeters. Okay. This is 3.925 centimeters here. Okay. Now from point T, V1 is emerging. So V1 is given, the velocity V1 is given 350 meter per second. So the velocity V1 is 350, but in terms of centimeter, 350 by 40. So 350 by 40 it is 8.75 centimeters. 8.75, this is in centimeters. Okay, then take it as 9, no problem. Okay, so the angle alpha 1 is 20 degrees. So keep the protractor on point D and measure the angle in clockwise direction. Measure the angle in clockwise direction because the alpha 1 is measured in clockwise direction. So the alpha 1 is 20 degrees and the length is 8.75 centimeters. So you will get the point A here. You will get the point A here. Okay, this is the velocity V1. V1 equals to 8.75 centimeters and alpha 1 equals to 20 degrees. Alpha 1 equals to 20 degrees. Now join AC here. Join AC. This will be VR1. VR1. And from A, drop a vertical line up to B here. Sorry. This is VF1. The flow velocity component VF1. This is a point B here. Now join DC. And this will be the angle beta 1. This will be the angle beta 1 here. Okay. So we can solve it further. Now here, from graph, we have to measure the magnitude of VR1, the length of VR1 in terms of centimeters. So you can write here from graph, the length VR1 equals to the length of VR1, length VR1 equals to the length VR1 in terms of centimeter, which I got is 5.1 centimeters. 5.1 centimeters. And if you multiply with 40, you'll get it in terms of meter per seconds. Meter per seconds. Okay. Fine. It's very clear. VR1 equals to 5.1 into 40, that is 204 meter per second. 204, it is in meter per seconds. Now you know the ratio. VR2 by VR1 equals to 0.86. So VR2 equals to 0.86 times VR1. Just multiply 5.1 into 0.86, 5.2 into 0.86 here. So 0.86 into 5.1 in terms of centimeters, you'll get it as 4.4 centimeters. So I have rounded off the value 4.4 centimeters. And similarly, by using the protractor, you can measure the angle beta 1. So keep the protractor on point C and measure the angle beta 1. So the value of beta 1 is the angle beta 1 is equal to 36 degrees. 36 degrees. And as we know that the blades are equiangular, so beta 1 will be equals to beta 2. Beta 1 will be equals to beta 2. So here you can write beta 2 as it is. Okay. Since it is equiangular, the blades are equiangular, so beta 1 equals to beta 2, that is 36 degrees. So from point C, VR2 is emerging at an angle beta 2. From point C, VR2 is emerging at angle beta 2. So keep the projector on point C and measure the angle in counterclockwise direction, that is 36 degrees, and take the line VR2 equals to 4.4 centimeters. 4.4, so you will get here 4.4 centimeters. So VR2, you'll get the same diagram. You'll get the same diagram. So this is of course point F here. This is of course the point F. This is the exact figure as per the scale, and this is a rough sketch. Okay. So the rough sketch may be different from the actual. Okay, what we have drawn on the graph as per the scale. Okay, fine. Now here, just join FD. This will be V2 here. This will be V2, and from F, just drop a vertical line. So that is VF2. VF2, that is flow velocity component. Remember, students, VF1 and VF2 are always vertical in nature. VF1 and VF2, they are the axial velocity component, which are always vertical in nature, whereas VU1 and VU2 are horizontal component. They are always in horizontal in nature. Okay, they are always horizontal in nature. Fine. Now let us proceed for the next important step. So this complete vector is delta VU1 or delta VU here, delta VU. This complete vector is delta VU, and this is beta 2 here. This is beta 2, and this vector, this complete vector is VU1 already. Already we have taken it as VU, delta VU, delta VU. Now what we need to calculate here? Here we need to get the value of the power P. So for power P, we know that the formula m dot by Gc into U into delta V. M dot by Gc into U into delta V. This is a formula to calculate the value of power P. But we don't know the value of m dot. Here he has given the value of axial thrust 120 newtons. So we know the formula axial thrust. We know that the axial thrust Fa is given by m dot by Gc into Vf1 minus Vf2. Vf1 minus Vf2. Here m dot is given by Vf1 minus Vf2 here. Okay. Now from graph we can measure Vf1 and Vf2. The values of Vf1 and Vf2 in terms of centimeters. In terms of centimeters, or else you can measure the total length Vf1 and Vf2, and just take the difference between Vf1 and Vf2. The difference between Vf1 and Vf2 is delta Vf. Okay, so Fa equals to m dot by Gc into delta Vf into delta Vf. The gap or the difference between Vf1 and Vf2. Okay, so let me draw here. This is Vf1, this is Vf2, and the difference between these two is delta Vf. Delta Vf. Now the difference between Vf1 and Vf2 is 0.45 centimeters. 0.45 centimeters. Okay, 0.45 centimeters. And if we multiply this with the scale, that is 40, because while substituting in formulae, we have to convert the velocity into meter per second, not in centimeters. So while substituting in these formulas, mandatorily we have to substitute the value of velocity only in terms of meter per seconds, not in terms of centimeters. Okay, this is the important thing. So the product is 18 meter per seconds, 18 meter per seconds. So let us substitute the value of delta Vf, that is 18 meter per seconds in this formula. Okay, fine. Now Fa is 120. Fa is 120 newtons equals to m dot as it is, because it is unknown. Divided by Gc is 1, and delta Vf is 18 meter per seconds. So m dot is the value of m dot will be equals to 6.67 kg per second. 6.67, this is in kgs per second. This is the value for mass flow rate. Now we have to substitute the value of mass flow rate in the power equation to get the value of power P. Okay. Now let us substitute. the value of m dot in this equation. Okay, so m dot is already known, 6.67 kgs per second. So therefore, the value of power P equals to m dot as it is 6.67 divided by Gc value is 1. Now U is 157 meter per second. 157 into delta VU is, see, the delta VU is total difference between B to this is E. B to E, because delta VU is nothing but the parallel distance between VF1 and VF2. VF1 and VF2. You should be very careful here. The delta VU is nothing but the total gap between the total length of point B to E, the line B to E gives you delta VU. Okay, you should be very careful here. Fine. So the delta VU is nothing but, if you measure by using the scale, delta VU is approximately equals to 7.8 centimeters, 7.8 centimeters, or if you multiply it with 40, you will get the velocity in terms of meter per second. The meter per second velocity is 312. 312, this is in meter per second. This is in meter per second. So this is 312, 312. And if we divide the complete term by 1000, you will get the power P in terms of kilowatts. You will get the power P in terms of kilowatts. The approximate value of power P is 326.56. 326.56. This is in kilowatts. So this will be the answer for power P, that is unknown. Okay. Now, if you are not subscribed my channel yet, so please subscribe my channel, like this video, share this video among your friends. Okay. So comment if you have any doubts anywhere. So just put your comment in the comment box. Okay. Or else, if you want the notes on this particular topic, just send the message on WhatsApp. So my WhatsApp number is 988 6539 074. 6539 074. So my name is Professor Manoj Shendre, and my channel name is Thermal Engineering by Manoj Shendre. I am the faculty in Guru Nanak Dev Engineering College, Bidar, Mechanical Engineering. Okay, so thank you and have a great day.